Hi there, I hope you had a fantastic long weekend. And now we're going to be looking at our first lesson of semester 2. And we're going to be talking about points of inflection and intervals of concavity. So that's a lot of vocabulary and we will definitely get there. Just a quick reminder that your quiz tomorrow is going to be on everything from the last 2 weeks. So it will have intervals of increase and decrease, and it will have mean value theorem. So if you need to brush up on that, if you want to ask me any questions, please do that before you get started on the quiz. So here we're going to be doing our part C from some of our homework when we were talking about intervals of increase and decrease, as well as we've got 2 other problems here. So as I said, let's get started and let's talk about what these new vocabulary words mean. So the first one I want to talk about is concavity. Now concavity is the rate the slope is changing. So what that means, it's the behavior of the second derivative. So there's 2 basic types of concavity. It says intervals, and that is positive and negative, just like with increasing and decreasing, but it's with the second derivative. So if I'm looking at the second derivative is positive, we call this concave up. And what it looks like is that it is sort of like a cup facing upward. So either it's coming down like this, or it's going up like that. And what you'll notice is that if you have something that's concave up, that you're going to have a minimum if you have a critical point there. So this is something that's just helpful to know. Concave up forms a cup shape like this. So if I'm looking at the graph in number 1, find the intervals where the graph is concave up or down. You know, it's hard to find the exact change point, but here would be a concave up shape. So there's something around here. And so it would be concave up on the interval. I'm going to call that negative 0.5 to 3. And alternatively, we have when f double prime, when the second derivative is negative, we call this concave down versus concave up, and concave down looks like I hope you would expect it to look like, is that it looks kind of like a frown. It's going, goes over like this, and we have a maximum if you have a critical point there, right? So here, if I'm looking at this picture, we have concave up from negative 0.5 to 3. And then here's the concave down section. From negative 3 to negative 0.5. And now we also have a point where it changes. At this point, we're approximating it from what it looks like at approximately negative 0.5. This is called an inflection point. So it's kind of like the concavity version of critical point. An inflection point is where the concavity changes. And just like before, we're worried about where the second derivative now is equal to 0. And it's not all the places where the second derivative is equal to 0. It's where it also changes from positive to negative or negative to positive, right? It's where it's doing a change. So that blue point there is approximately the point of inflection of our graph in number 1. Now, of course, you can do it graphically. You also maybe are interested in looking at it algebraically. So here, given f of x is equal to 5 minus 3x squared plus 3x, find the following: the intervals of concavity and the inflection point, or points, might be more than one. So the first thing that you want to do, just like before, is find where, in this case, f double prime is equal to 0. So the first thing I'm going to do is find the second derivative. I'm going to use the power rule and start by saying, well, f prime is equal to negative 6x, because 5 has a derivative of 0, plus 3x squared. Now I'm going to take the derivative again to find the second derivative, which would be negative 6 plus 6x. Now, since I want to find possible inflection points, set that equal to 0. And in this case, we only have one inflection point where x is equal to 1. Now, again, similar to what we've been doing before, we're going to set up a number line and test. The only difference, of course, here is that we're still looking at our possible x values. We're really going to focus around 1. And then here we're looking at f double prime values, our second derivative, and we'll just test ones on either side. In this case, 0 and 2. We know that there is a possible inflection point at x equals 1. And I'm just going to plug in and say, okay, well, what's f double prime of 0? Well, that's negative 6, so this one's negative. And f double prime of 2 is equal to negative 6 plus 12, which is positive 6, so it's positive. Therefore, what we can say is that we just want to make our conclusions. So for A, it's concave up where it's positive, so that's from 0 to infinity. Whoop, not 0. X equals 1 to infinity. That's the positive here. And then we have our concave down, our negative. Give myself a little bit more space. From negative infinity to 1. And since it's changing, we have an inflection point at x equals 1, which means that we want to find the entire point. So what's f of 1? It's 5 minus 3 plus 1. So the actual point of inflection, x is equal to 1. And f of 1 is 3. So you might see it in either case. If you have questions about any of these intervals, about second derivative, about first derivative, about critical points, concavity, and of course then the mean value theorem, please let me know before you see it on the quiz tomorrow. Talk to y'all later.